So we're going to be looking at two different types of sequences, an arithmetic sequence and a geometric sequence. So our concentration is on an arithmetic sequence today, and that is where the terms are generated by adding or subtracting a fixed amount. So adding or subtracting a fixed amount, that is an arithmetic sequence. And an arithmetic sequence has this thing called the common difference. The common difference we call D, and it is a term minus the previous term. So if you like, it is just the difference between the two terms. So T2 minus T1, T3 minus T2, T4 minus T3, and so on. So let's just have a look at an example here. Which of the following sequences are arithmetic? If it is an arithmetic sequence, find the difference and use it to find the fourth term. Now, we've got to make sure that there is a common difference between all of the terms in the actual sequence. So let's check it out. 28 minus 21 is equal to 7. 35, take away 28, is also equal to 7. 42 minus 35 is 7. So we've looked at every single combination there, and we can see that our common difference is 7. It is the same between all of the terms, and so therefore that is an arithmetic sequence. So therefore an arithmetic sequence. And the question does say to find the fourth term, but the fourth term is already there. So let's find the fifth term, which means what we need to do is add on 7. So the fifth term would be equal to 42 plus 7, which is 49. So let's now have a look at the next one. 2, 6, 18, 54. And we're going to do exactly the same thing here. So 6 take away 2 is equal to 4. 18 take away 6 is 12. So straight away we don't have a common difference, and so therefore it is not an arithmetic sequence, and we do not therefore have to find the common difference because there isn't one, and we won't find the fifth term. So the first one was an arithmetic sequence because it had a common difference. The second one was not. The instructions here show a really easy way to generate an arithmetic sequence on your CAS calculator by just putting the number in, pressing return, and then plus or minus the common difference. We will go through that in class. Now, if it's an arithmetic sequence, let's think about it. We're going up or down by a constant amount. What sort of a graph do you think that might produce? Hopefully you are saying that it is a straight line graph. So points along a line with a positive slope when our common difference is greater than 0, which means our value would be a positive D. And when we have a negative D value, we end up with a negative slope, and therefore we're talking about D less than 0. Let's have a look at that in an example. The sequence 4, 7, 10 is an arithmetic sequence with a common difference of 3. So common difference of 3 means that we are going up by 3. And we can see that 4 plus 3 is 7, 7 plus 3 is 10. Part 1 there wants us to construct a table showing the term number, which is n, and its value, Tn, for the first 4 terms in the sequence. Well, we've got the first 3, haven't we? When n is 1, Tn or T1 is 4. When n is 2, T2 is 7. When n is 3, T3 would be equal to 10. And because we know we're going up by 3s, when n is 4, T4 is 13. That is our table. Part B, or part 2, wants us to use the table to plot the graph. Now, we've talked about the fact that an arithmetic sequence should be a straight line graph. Let's have a look. So let's start off by constructing our axes there. Tn is on the vertical axis and n is on the horizontal. So n is going up in ones right through to 4, and our Tn value goes up to 13. So I've decided to go up to 15, and I've gone up in 5s. Obviously a smaller scale is going to be better there, but let's see if we can plot those points now. So 1 and 4 would be there. 2 and 7 would be around about there. 3 and 10. Of course, if you had some graph paper, it would graph much nicer for you. And 4 and 13 would be around about there. Can you see that we have produced a straight line? And the gradient of that straight line is your common difference. So that common difference produces the gradient of your straight line. Part 3 there asks us to describe the graph. Well, we've already talked about the fact that it has a positive slope because we have d equal to 3, or our gradient equal to 3. And therefore, we could probably make this statement. So the things that we want to include in our statement is the fact that it is a straight line and not a curve. And we have indicated that there. Okay, and we also want to talk then, if we talk about the fact that it is a straight line, we want to indicate that it has either a positive or a negative slope, which we have done there in our statement. So they're the two important things we need to include when we are describing that graph.